Hello everyone and welcome to BioSense, an IoT system for indoor plant care, monitoring health and offering personalized recommendations for growth. Indoor gardening has been on the rise since the pandemic due to an increase in trends pertaining to interior design, green technologies, and greenhouses. With 72% of adults owning a houseplant, with that number being 80% in individuals between 16 to 24. However, the problem is that nearly 500,000,000 of houseplants are discarded due to plant diseases, which stem from inadequate care from a lack of knowledge. This often leads to a release in methane gas, which pollutes the air. Discarding them prematurely wastes water, energy, nutrients, and the efforts that went into their cultivation. There's also an increase in stress and a decrease in attention span. The chart here shows the percentage of people who throw away plants, which is a staggering 67%. Our solution, we saw that there was a lack of applications which aided in deterring plant waste and educating individuals on looking after their plants. Therefore, we created an IoT indoor plant care system monitoring health and identifying diseases. It's a user-friendly interface and recognizes 10 different plants with 5 different care tips for each. Here we can see the mobile application with the plant metrics on the side, the luminosity, the age, temperature, humidity, and soil moisture, as well as a chart here, and then the AI, which would allow you to scan for diseases either by taking a picture or uploading a photo. Pertaining to its execution, for the web app, we use Next.js, Tailwind, MQTT, and Prisma, as well as TypeScript. For the IoT, we use ESP32, soil moisture sensor, temp and humidity sensor, light-dependent resistance sensor, 1x relay, 2x LED, 1x BC547 transistor, and some resistors in MQTT. For the AI, we use Google Colab to code the model needed and train it. The base model architecture used for this task was BGG16, and we're using the Keras from TensorFlow and Python. The plant data was taken from RealSimple. How it links to sustainable goals. So there's 3 sustainable goals that we are taking down here. One being good health and well-being, indoor plants, enhance air quality, as well as overall well-being. The second one is industry, innovation, and infrastructure. So through employing plant vital monitoring systems, advancing smart agriculture and sustainability. And through responsible consumption and production, indoor gardening promotes water and energy efficiency in combating climate change and biodiversity loss. And thus, through ensuring that plants are looked after carefully and there's less waste, we're able to tackle 3 of these goals. The impact that we're hoping to create is that users can create an optimal environment for their plants. It increases overall well-being, as well as there being a decrease in disease and pests. Now, for the larger agricultural business, it would encourage water conservation because an irrigation system can monitor soil moisture levels and weather conditions to optimize water usage. And it can also help farmers apply fertilizers more precisely and when necessary, which would lead to less environmental pollution and biodiversity conservation. Now to our demo. Hello and welcome to BioSense, an IoT plant monitoring system that helps owners correctly look after their plants and identify diseases. So on the left side is the app application and on the right is the IoT side. So just with a quick demonstration using the aloe vera plant, we have the plant metrics on the left-hand side. So the light bulb, which controls luminosity, we can see showing up on the sensor there on the right. The same with the moisture. So you can see the water coming out. And we can check the soil moisture percentage, the humidity, the temperature, the luminosity, and how old it is. If we go here, we can see that we've clicked on luminosity. We can see if the temperature is okay. We can see if the humidity is okay, as well as the soil moisture. So, in scanning for diseases, we have implemented AI, which is based on VGG16. And it was trained using thousands of images. We're just going to use 2 images today. And it was fine-tuned with our own data. So we can see that it scans here. Then it says 100% healthy. There's 0 rust, 0 powdery mildew, leaf spot, etc. If we now want to check for one that is not healthy, it will scan again and it will show that it has a leaf spot, it has rust, there's mold, anthracnose, as well as other issues with the plant. Thank you for coming. Thank you.